My name is THEKISO. As Ntate Mohapi has already introduced me. Ntate Mohapi, please go to the multiple choice, and then so that we can have a moment to check with the colleagues if there is anything that they have an input on, because we believe everything so far is still as it is. So we can hear from colleagues if they have got any inputs or suggestions on multiple choice. Otherwise, we can continue. That I'm happy without any waste of time. If there are no questions on multiple choice, please let us then go to question asked 2.1.1. It required a definition of a standard solution. And on the memo stands that I'm happy. A solution of precisely known concentration. Or we can also say a solution of known concentration, meaning the word precisely can be put in brackets. A solution of known concentration. For 2 months. Yes, we then continue to question 2.1.2, which says calculate the concentration of magnesium carbonate. And then on the memo,
okay,
is there somebody saying anything?
No, sorry, Minier, there is Mr. Mancini. Can you please switch off your mic and your camera?
All right, and then the memo for 2.1.2, we've got 2 options there, where option 1 is about using the expanded formula of concentration, C equals to M over MV, 1 mark for that, and the substitution of the mass divided by molar mass, and then at the bottom they multiplied by 0.25, which is the converted volume. Then the answer stands as 0.238. However, because the rounding off rules are there, you can also award learners if they are saying 0.24 mole per dm cubed as an answer. So the 0.24 mole per dm cubed is a correct answer if the rounding off has been done. Otherwise, every digit is also welcomed after the comma as 0.238 or the full set on the calculator. And we have option number 2 on this, where we are calculating first the number of moles using n is equal to m over m, no mark, and then the substitution into that formula being 5 over 84, still no mark, and then it gets you the number of moles as 0.05952 mole. Therefore, we go to the formula of concentration, which is what we need. C is equals to N over V. That's where the first mark will be allocated. And then the substitution into that formula as what we have calculated above, 0.05952 divided by 0.25. Then the answer is equal to 0.238 mole per dm cubed, or 0.24 mole per dm cubed. And that will be for 3 marks. And we move on to question 2.2. And then the 2.2 says 50 centimeter cubed of magnesium carbonate solution is reacted with 25 centimeter cubed hydrochloric acid solution of concentration 0.25 mole per dm cubed according to the equation below. And the equation below is given. And then 221 asks for the name of substance A, which is a salt. And then that salt is called on the memo magnesium chloride for 2 marks or nothing at all. Magnesium chloride. And 2.2, it says you must use a calculator to determine the reactant that will be completely used up. And on the MEMO stands the formula of concentration. We are doing these calculations twice. As such, we have afforded this formula a mark yet again, 1 mark for either side that you see either for magnesium carbonate or for hydrochloric acid. And the second mark goes to, let's start on the left-hand side, where we have the positive marking for the concentration value we have calculated above at 2.1.2. So on the left, it's the positive marking 0.24 or 0.238 being equals to n over 0.05. And that entire substitution deserves another mark. And then the calculation of the number of moles comes out as 0.0119 mole for magnesium carbonate. And then after that, we then divide this calculated magnesium number of moles. We divide it by the ratio which appears from the balanced equation. So in front of magnesium carbonate, the coefficient is 1. So dividing that by 1, it will still give us the 0.019 as a number now, because now we no longer have the units. And then we move to the right-hand side where the C squares to N over V was already allocated a mark, and the substitution of the concentration given 0.25 equals to number of moles of 0.025. That entire substitution gets the third mark, where the third mark is allocated. And after calculating this number of moles, then we divide by the stoichiometric balance, which is coming from the equation there, then it is 2. So what you see there is 0.0625 dividing it by 2. So if already you are seeing that this learner, for both reactants, they have divided by the stoichiometric balance, that learner will get 1 mark for that. So that will be our 4th mark. And then the numbers that they have calculated as 0.019, 119, and 0.003125. Those numbers will then determine the substance that will be completely used up, or the limiting reagent. So the smaller one, the smaller number, the smaller ratio will be the one that will determine our limiting reagent. And as such, it is hydrochloric acid. And it also gets 1 mark for 5 marks on question 2.2.2. And then we move to the last question on question 2, which is 2.2.3, which then asks for the volume of carbon dioxide that has been formed at STP for 4 marks. On the MEMO, we are also doing positive marking from question 2.2.2. Actually, the calculated number of moles from the CNV formula, those calculated number of moles will move forward into this question. The first mark is allocated, therefore, to the ratio that is between the limiting reagent and the product, which is CO2. So 2:1 is the ratio for 1 mark. And then after that, they are using this real moles that they are having, which is 0.00625 mole for hydrochloric acid. That will react all of it. And they are also looking for the real moles of carbon dioxide that will be produced. And by cross multiplication, they are going to get 0.003125 mole. And thereafter, they are then using the formula of N is equals to N over Vm for calculating the volume of carbon dioxide that was produced at STP. That formula gets a mark, so that's the second mark. And then bringing that 0.03125 equals to V over 2.4. Then that substitution into the NVVM formula also gets the third mark. And the last mark is for getting the answer by cross multiplying there as 0.07 decimeter cubed. And that will be the fourth mark, only 2 to 3. And the total for this question is 16 marks. And then we can stop here. And that Nambani, that I'm happy for questions if there are.
No, thank you very much, THEKISO. Colleagues, do we have any questions on question 2? Yeah, please raise your hand. I see a hand of Sarah.
And we are way too young. Could I call an old person like me to come and sort out?
Thank you, Ndate Mahapi. Can we go to question 2, 2, 3? Hello?
Yes, sir.
Can we please go to question 2, 2, 3? Let's say therefore now a learner on the memo, thank you. Suppose a learner picked a wrong limiting reagent. And then now, how are we going to mark 2, 2, 3? Are we going to give a mark for the formula and the substitution of 222,4?
Okay, all right. And that you will advise here, however, if they have picked up the wrong limiting reagent, I would say they should not get, meaning it will be magnesium carbonate, so their ratio is going to be 1:1, which is not correct, but it's what they think. And then I believe they can get the mark there for VVM, the formula, and the substitution only 2 out of 4. That I'm happy you will advise.
Thank you.
I agree, Miniria. Thank you. Any other question, colleagues, before we move on to question number 3?
I have seen the post there, somebody was asking about what if the learner wrote MgCl2 on 221, and 221 is specific, and then it's written, give the name. The name is written in capital letters, so we only accept magnesium chloride as the correct answer. The formula or any other thing else is not acceptable.
No, thank you very much, THEKISO. I think we can now move on to question number.
All right, thank you very much, Mr. Happy. Let's move then to question number 3. Question number 3 says an unknown mass M of calcium carbide reacts with water to produce ethine and calcium hydroxide according to the following equation. The equation is given, the equation is balanced. The graph below shows the changes in mass of calcium carbide until the reaction reaches completion. And the graph has been drawn there up to, it's an increasing function exponentially, so it ends at 0.7 there. So then it says the actual mass of ethine produced is 3.25 grams. And then 3.1 says is calcium chloride a limiting or excess reactant for 1 mark. And then according to the MEMO, it says it is an excess. And of course, because the graph there does not touch the x-axis or the time axis or the horizontal axis, so indeed this calcium carbide is an excess reagent. And then 3.2, it says if the percentage yield of C2H2 is 76.8%, calculate for 3-to-1 the theoretical mass of ethine. Then on the MEMO, we have written the formula of percentage yield is equals to the actual mass over theoretical mass multiplied by 100. That does not get a mark. And then the substitution of the percentage yield as 76.8 gets a mark. And then the fraction multiplied by 100, that is on the right, which is 3.2 given, divided by the theoretical mass multiplied by 100. The entire substitution with the 100 also gets 1 mark. And then they will then therefore get their theoretical mass as 4.23 grams. And then 3-to-1, therefore, is 3 marks in that way. And then we move to 3.2.2. Unknown mass of calcium. You need to calculate the unknown mass of calcium carbide that initially reacted with water. And then on the MEMO 3.2.2, the ethine, we start by using by calculating the number of moles that are there actually or initially. So N is equal to M over M. It doesn't get a mark, but the substitution into that being the given 3.25 dividing by the molar mass of ethine, which is 26. So 3.25 over 26, the whole substitution, the whole fraction gets 1 mark. And then later, learners will get the number of moles as 0.125. And then now that they have this 0.125, they go to they're going to do the comparison of the actual mass that's there and whatever that needs to react. Then their ratio will therefore be 1:1. It gets a mark. And then after doing that, they will find that the reacted number of moles of calcium CaCO2 is the same as 0.125. Then they therefore calculate the CaC2 mass that has reacted with water using the formula N is equals to M over M, which gets a mark. And then the substitution into that formula is therefore says is a substitution that they have calculated, the answer that they have calculated as 0.125 being equals to M over 64. So this mark is allocated for the left-hand side and the denominator of 64. So that multiplication with the M at the top as an unknown, and they get the mass of 8 grams. And what they therefore do is that, okay, then they will say, okay, there are 8 grams, but there was also 0.75 that was not used. So in total, there was 8.7 grams. So the addition of 8 plus 0.7 gets a mark, and then the answer will therefore be 8.7 grams. And this question, 3.2.2, will be for 6 marks. 3.3, it says calcium hydroxide, CaOH2, can react with hydrobromic acid to form calcium bromide, which is used as a sedative in medicine. Calcium bromide is made of 20% calcium, 80% bromine. Determine the empirical formula of calcium bromide. Then what was done there was the mass percentage was shown, and then that mass percentage on the MEMO has been divided by the atomic mass of each substance, calcium and bromine. So it's 20 over 40 gets 1 mark, and then 80 over 80 also gets the second mark. Then it will be found that the ratio is 0.5:1, and then that 0.5:1, if it is being multiplied by 2 so that we can get the whole number. and then it gets a mark. So the second mark, the third mark goes to multiplying both 0.5 and 1 by 2. So it will be the third mark, and then writing the empirical formula as CaBr2, then gets the fourth mark. And the total for this question will be 14 marks in question 3. If there are any questions.
Thank you very much, Ndade THEKISO. Colleagues, you can, by show of hands, ask a question. I don't see hands, but I think we have something on the chat, but they are taking us back to question number 2. We have from Vikas. So am I correct in saying question 2.2.3, if the answer got incorrect limiting reagent, then we only mark positive value used, award a full mark, but the learner will forfeit the ratio as well as the answer. So in total, it is then not overall positive marking, just the mole ratio calculated in 2.2. I think, Minir, you responded to this, but if you can just emphasize that.
All right, because for that one, yes, we are only marking the formula and then the substitution of whatever that they were trying to calculate, meaning into the VVM, yes. So let's assume they have, because they used 1:1 there, and then they will be saying this is 0.019. So you will be marking the 0.019 multiplied by 22.4, not the answer. So they won't get the mark for the ratio which is not correct, and then the answer that is not correct. So we're just saying you will afford them the marks for the formula of VVM and the substitution into the VVM only. So the total, there should be 2 out of 4 if they are identifying the incorrect limiting reagent. 2 out of 4.
Are we okay, Vikas? Is that clear? Please indicate in the chat if you can't speak. Besides that, I don't see any question. Minir, Vikas says okay. Then maybe we can then move on to question number 4.
All right, thank you. And then question number 4 says ethene gas and hydrogen gas react to form ethane gas according to the following balanced equation, and the equation is given with the delta value at the end. The activation energy for the reaction is 560.32 kilojoules per mole. 4.1 then asks, is the above reaction endothermic or exothermic, and provide a reason for your answer. So on the MEMO stands, it is exothermic reaction. So we will give them the mark for choosing the type of the reaction, and their supporting statement can be either of the following. They can write delta H is less than 0. They can get a mark if that is their reason. Or they can choose to say delta H is negative. They can get a mark. Or they can say more energy is released. They can still get a mark. Or the other one can say the energy of the reactant is greater than the energy of the product. So any of those choices, 1, 2, 3, 4, any of those 4 supporting statements or phrase, okay, for the second mark. So 4.1 will therefore be for 2 marks. And then we move to 4.2, which asks for a definition of activation energy. And then it stands like this: the minimum energy needed for a reaction to take place, for 2 marks or nothing at all. So the minimum energy needed or required for reaction to take place, 2 marks. And then 4.3 says sketch a potential energy versus reaction coordinate graph for the above reaction. Clearly label the X's and indicate the following on the graph. They are required to indicate the reactants and the products. They are required to indicate the activation energy for forward reaction. They are required to also indicate the activated complex with the letter X, and then also indicate delta H position. And then on the memo, there is a graph. Yes, thank you. That I might move to the criteria there so that you can read the criteria. The first, or let me just say, one of the marks should go to both indication of reactants and products at the right place. So that would be the first mark. And then the second mark will go to the activation energy for the forward. And then remember, this learners can choose any position as long as that activation energy is starting at the energy of the reactants up to the activated complex. So they can put it in the middle, they can put it on a side, left, right, it matters not. So for as long as the distance is correct, then they will get the second mark. The third mark then goes to the activated complex right there at the top, there at the peak. If it's written X there, then we can give the learners a mark. Or if they point to it, then and they write activated complex, we can afford them a mark. There, though we have clearly said they must write them with an X. So afford them a mark if they are pointing that apex and writing activated complex. And then the fourth mark goes to delta H, and delta H being the distance that is between the reactants and the product. So if they are showing that distance correctly and indicating that is the delta H, then they can get a mark for that. And then the last one, that will be for the correct shape, where actually the energy of the reactant is greater than the energy of the product. So that will be the fifth mark for 4.3, which is the graph. And please, for the delta H, do not give a mark if it is left there without showing the distance. If they are just writing delta H, we are not going to assume that we know that it starts from the heat of the reactant up to the heat of the product. So no. Then we can move to 4.4.1. Question 4.4, it says for C2H6, which is ethane, it breaks down to C2H4 and H2. Write down the values of delta H as 4.4.1. So delta H will then now be positive 263.54 kilojoules per mole. So that will be for 1 mark. And if these learners are writing 263.54 kilojoules per mole, we'll take it as the correct answer because the positive does not necessarily need to be explicitly shown. So 1 mark for 263.54 kilojoules per mole. And then 4.4.2, they are required to write down the value of activation energy for the breaking down reaction, for the decomposition now. So then they will then say the activation energy is equal to 560.32 plus 263.54. Then it will be equals to 823.86 kilojoules per mole. Here, Dr. Mohapi, you will correct me if I'm not stating it correctly. I think we can give 2 marks if learners are only showing us 823.86 kilojoules per mole because the question asks them to write down the value. So I believe with guidance, 823.86 kilojoules per mole can be awarded 2 marks if the step of addition is not shown. And this is 2 marks, and the question 4 is totaling to 12 marks. That I'm happy.
No, I agree. I was even I was myself thinking about that, Mineria. If the learner just gives the answer for the last question, then they can get full marks. Yes, because the phrasing of the question says write down the value of the activation energy for reverse reaction. That's that for question number 4, colleagues. Do we have any clarity-seeking questions? I just want to check in the chats. We don't have anything. We also do not have hands. No, we are doing good in that THEKISO. Oh, we have Mutsamai. You can just unmute Minir and then shoot.
Good morning, Minir.
Minir.
Thank you, sir. I just wanted to ask, I'm more worried about question 4.4. The concept of a reversible reaction. I think if I understand to be corrected, it's introduced in grade 12. I'm not sure if it's prescribed for grade 11.
Okay. Are you done, sir?
Yes, sir.
All right. Yes, we have discussed this before, Linda Temohapi, but we avoided exactly those words of writing the reverse reaction here, because now when you look at the given reaction above, it's the forward is negative, and then we rewrite the same equation, but now in reverse without even saying it is reverse. So that delta H needs to change to positive.
Okay, Minir, no, I understand, sir. I understand. Yeah, the reason why I'm saying is that when I teach, I don't know about other educators. When I teach, I don't go back and say, if you reverse it, or if you avoid saying the word reverse, but if you go the other way. So personally, I feel it's going to disadvantage my learners on that regard, because I did not show them that going back delta H will be positive, and the activation energy will be this much. But I understand what you're saying. I think it's something that one needs to note moving forward. Thank you, sir.
Thank you, Ndate Musamai.
Yes, colleagues, let us please note that I understand already the concept there, reversible reaction, is not explicitly indicated in the examination guideline and the ATP, I presume. But please let us, for the purposes of the application of the principles, let us also indicate to the learners, or if this was to happen this way, this is what will happen. So that is basically where we are coming from with this question. And I'm sure colleagues will agree, or this is how this thing is assessed in grade 11. So let us make our learners aware, or if it were to happen in the reverse reaction, or reverse reaction, this is what will happen. So let us make our learners aware of such as we prepare them for grade 12 as well, colleagues. So thank you very much, Ndate Mutsami, for that. Let us go back, colleagues, and do it with our learners. Even on I think on the issues of acids and bases, the questions of reversible reactions are there. So let us indicate or show our learners such things. Okay. And besides that, I don't see any other question that is tricky. So I don't know from your side, did you see anything?
No, that I did not see anything. I don't know on the chat, because I'm not checking the chat so that I can focus on the memo. If there isn't
no, there's nothing.
Okay. Let us then, I propose we move to question 5 in Tatem.
Hey, we are moving that. We are moving. Okay, thank you.
All right, question number 5. It says, nitric acid is a strong acid used, among others, in the manufacture of fertilizers and explosives. 5.1, define an acid in terms of Arrhenius theory for 2 marks. And 5.1 MEMO says, acid is a substance that produces hydrogen ions or hydronium ions when it dissolves in water. So here there is part marking. So you will mark it for anything, for seeing the production of hydronium ions, and the hydronium ions can be written as a formula like that as H plus, production of H plus upon the production of H3O plus. So that's where the first mark should be awarded. And then it must be stated that when it dissolves in water as the second mark. And in that I'm happy you will guide me, because in a leader examination guideline, it's saying that there are some examination guidelines that says when it dissolves in aqueous solution. So perhaps on those bases, we can accommodate when it dissolves in aqueous solution, but you will get that I'm happy there. So that's where the second mark will be going to. 5.2. says a 0.9 grams sample of impure potassium hydroxide is neutralized by a 0.25 mole per dm cubed of nitric acid solution with a volume of 30 centimeter cubed. 5.2 therefore asks that learners should write down the balance equation for this reaction. And then the balance reaction will be KOH plus HNO3 as reactants. And then the arrow forward, that I'm happy. Thank you. And then the arrow forward to show that there is now yield or production, then we'll be producing the salt KNO3 plus H2O. And then by merely looking at this reaction that it's balanced, that will be the third mark. So the first mark goes to the writing of the reactants in any order. It does not have to start with KOH. So in any order of writing the reactants, but with a plus. So both of them are there, 1 mark. And then there is that arrow that shows us that we are producing salt and water. Then that's the second mark for KNO3 plus water. So in any order as well for those products, the second mark. And then because this reaction automatically is balanced, then that will be the third mark. But learners will not get the third mark if those substances are not correct. So that will be for 3 marks at 5.2. And then 5.3, give the name of the suitable indicator for this neutralization reaction. Because on this reaction, we have a strong acid, we have a strong base, we will then require bromothionyl blue for 2 marks. So colleagues, please note it that it is 2 marks there on the memo. So that will be 2 marks. 2 marks for bromothionyl blue. So it's 2 marks or nothing. So 5.4, on 5.4, it says calculate for 541 the number of moles of nitric acid that neutralized potassium hydroxide for 3 marks. Then we use the formula of concentration, C is equals to N over V for the first mark. And that I'm happy on the memo. Yes. And then 541, the formula of C is equals to N over V as the first mark. And then the substitution into that formula, 0.25 for concentration. The N is still unknown. And then the volume that has been converted as 0.03. That will be the second mark. And then the third mark will be awarded for calculating correctly 0.0075 more. So that is what they are getting for 3 marks. And then again, I know we are going to be asked about the rule of, they can round off to 2 decimals. So 0.01 mole will then be correct. 0.01 mole will be correct if there was a decision to round off to 2 decimals. And then 5.42, it says calculate the percentage yield of potassium hydroxide sample. Calculate the percentage purity of KOH sample. And then 5.42, we will positively be taking our calculated number of moles from 541 as either 0.0075 or the 2 decimal 0.01. So we will be forwarding it to 542. So then what we are marking there, the first mark will be awarded to the ratio between the calcium hydroxide and the nitric acid as 1:1. That's 1 mark. And then it means the potassium hydroxide is still 0.075. Then it means now learners are going to be calculating the mass, the reacted mass of calcium hydroxide. And then it will be, if we are using the 0.075, then to substitute there, that will be 0.075 is equal to m/56, which is the molar mass of KOH. Then that substitution into NMM formula will get the second mark, and then getting the mass that has reacted of calcium hydroxide will be 0.042. And then going into the formula of percentage purity, then they are going to be writing that formula down. We will award them a mark. Percentage purity is equal to the mass that has reacted over the total mass that is available, which is the mass of impurity or the mass of the sample. So multiplied by 100. So if everything that you see there as the formula written with 100 as well, they get the third mark. And the substitution into that purity formula as 0.42 over 0.9 multiplied by 100. So that will be getting the fourth mark, and their percentage purity will be 46.67% for using the 0.075. However, if we will provide this one later, if learners then decided to use 0.01, then I will take it from the second mark. So the first mark will still be the ratio, and then substitution into the n is equals to m/m, it will be 0.01 on the left equals to m/56, and then learners will be getting the mass of 0.56 grams, and then they're going to go into that purity formula, which will still get their mark, and then they will be taking their 0.56 divided by 0.9 multiplied by 100. They will get a mark there, and then they will going to come out with their purity as 62.22% for 5 marks. And then question 5 will be reaching the total of 15 marks. Is that more happy?
No, thank you very much, THEKISO. Colleagues, do we have any clarity-seeking questions on question number 5? From my side, I don't see any question, but then I received a message here about the standard solution. And Ferra noted, I'll just come to you. I received a message about the standard solution. Colleagues, if we look at our FS AG. Page, I just want to look at the page here. I have it with me. I wanted to open it up there. But in any case, week 3 of term 3, we have an informal experiment number 6, preparation of standard solution. I know in the examination guideline, remember these things, these examination guidelines have not yet been, I don't know, formalized. So we are still using our ATP and FSAG as the principal documents. So there is an informal experiment on standard solution, colleagues. The concept of standard solution, we take it from there, colleagues, from the ATP and FSGA, our Free State Assessment Guideline, informal experiment number 6. I hope I'm responding to a colleague who asked about the concept of standard solution. So it is there. We are supposed to do it as an informal experiment in grade 11. Thank you very much. And Tatele Ferra.
Thank you, Dade Mahapi. I think we have got, I think, let me say it's a common error that even with the grade 12s we do have. Let us go to 5.2 on the memo. I think that was even addressed.
I'm happy. Hobanyane, I believe, let me see, is this reaction really reversible? I was trying to think of hydrolysis, whether we need to decide to afford them a mark or not. Now I would say no, because I don't think I need assistance. I don't think when we take this salt and react it with water, it will give us the same. I'm not sure at this point. I would say no. But colleagues can assist. That I'm happy that so assistance there.
Yeah, because we want to keep the standards as those of grade 12. I don't remember how do we mark when we have an equal sign. But can you please get an advice from colleagues? Anyone? I have circuit 5.
Good day, colleagues. I guess everyone good.
Yes, we can hear you, May. Thank you very much.
In grade 11, we would like to penalize actually, but hey, let us give let us mark as though KKR. So 1 mark for the reactants, 1 mark for the products, 1 mark for balancing. And then because of the equal sign, penalize 1 of the marks. So maximum will be 2 out of 3. But in other words, like we mark in grade 12, for us to be able to mark the reactants, if we see that equal sign, we'll mark the reactants. If we see that equal signs, we'll mark the products, and then we'll still give the balancing mark. But then because of the equal sign, we'll take 1 of the marks. So it will be 2 out of 3 if there is no mistake. In other words, if there is another mistake, we will take a mark because of that mistake. Thank you. Thank you, colleagues.
Thank you, Mebusi.
No, thank you, Mebusi. I think it is clear, colleagues. Thank you very much.
Thank you. Are there any questions maybe that are still requiring response?
I saw a hand from Fezile Dabi, circuit 5. Yes, I can hear you, Minin.
Yeah, no, no, I wanted to say the same thing as well, that the marking criteria says nothing about that, but we need to take into cognizance that these kids have to write it the right way. So we can give 3 marks and then subtract 1, precisely because they shall have used the equal sign. So I also concur that it be 2 out of 3.
Thank you. All right, and
right. Thank you very much.
If there are no any further,
we have Madondo.
Yes, I have a problem with 5.4.2. So if you look at the memorandum there, they have allocated a mark for the formula. Q rate equals to mass reacted divided by mass of the impure sample times 100. So that formula doesn't appear on the information sheet. So how about we just mark 0.42 divided by 0.9, because that is the application that the learner has used the formula. Even the learner did not write the formula.
Okay, thank you, Ntate Madundo. Ntate Mohapi, is that worth considering given how we do not have this formula? Or should we perhaps maybe bank the suggestion for later and then discuss it and finalize, send the finalized memo?
Yeah, no, I think Minir has a point. Even for consistency, I think we had from question, what was it? Let me go up, question 3.2.1, because there is no mark on that formula. You see it, Minir?
Yes.
Yes, and I think, yeah, Minir, I think we have a point. Maybe we can give 2 marks on the substitution here. Yeah, no, thank you very much, Mr. Madondo. That is well captured and then will be effected on the amended memo. Thank you very much.
It's the ratio, your night cell should be given a mark and everything's there's the second mark. Keep clear on that.
Which ratio? This one?
Yeah, the 0.42 over 0.9. Is that where we actually allocating the first mark, or we just allocating 2 marks all at once?
Yeah. Now we'll discuss it. We can give it 2 marks. It's fine.
All right.
Yeah.
Okay. Something on the chat tab from Tom Speck.
Yeah, okay, 5.4.2 colleagues, the multiplication with 100 on the formula, is it multiplied by 100% or just multiply by 100?
By 100. It's actually by 100.
Yeah.
Yeah, the percentage can be removed. Yeah.
Yeah, no, it's fine without a percentage, yes.
Yes, it's fine without a percentage. Yeah, without the percentages.
Yeah. Now, besides that, I don't see anything. I think we can then move on to question number.
Question number. All right. Question number 6, colleagues. It says phosphoric acid reacts with water in 3 steps as represented by the equations below. There is step 1 reaction, step 2 reaction, and step number 3 reaction as shown. 6.1 then asks for a definition of the word ampholyte for 2 marks. And we go to the memo where it says it is a substance that can act as either an acid or a base for 2 marks. Substance that can act as either an acid or a base for 2 marks. 2 marks or nothing. 6.2, it says write down the formulae of 2 species that act as an ampholyte in the above reactions. And from the above reactions, what can be determined is that H2PO4 minus can act as a base and can act as an acid. Also, the HPO4 2 minus can act as an acid and a base. So those are the 2 species that are acting as an ampholyte. So 1 for each one in any order. We can start with the 2 minus, we can end with the minus. So that will be 1 for each. And then 6.3, consider the reaction 1 and write down the name of the conjugate base of 630 plus 631. From 631, the name of the conjugate base will be water for 2 marks. It wants the name, not the formula. So if they give the formula, they get absolute 0. And then question 632 says, consider that reaction 1 and write down the species that indicate the acidity of the solution. So the species that indicates the acidity is H3O+, or they can give it as a name, hydronium ion. So it's the hydronium ion that is telling us that this solution is acidic for 1 mark, like 632. And then 6.4 says, consider the reaction 2 and write down the conjugate acid-base pair or pairs. Pair. Write down the conjugate acid-base pair for 2 marks. And then in reaction 2, we have these 2 pairs. We can either choose H2PO4 minus and H2PO4 minus. H2PO4 minus and HPO4 2 minus. So that pair, 2 of them, they will get 2 marks. They must be paired in that fashion or nothing. Else, learners can choose to say, I'm gonna take water and hydronium ion together as the conjugate acid-base pairs. So that is what it is for 2 marks. And then in any order, so they can start with the 2 minus and with the minus, or they can start with the H3O plus and end with water for 2 marks or nothing. And then we move to 6.5. 6.5 says, consider reaction number 3. And then 651 says, HPO4 2 minus is a Lorry-Bronsted, and then they needed to complete that statement. So HPO4 2 minus is a Lorry-Bronsted acid on 651. It's a Lorry-Bronsted acid. And then 652, it is saying PO4 3 minus is a conjugate base of, so on the MEMO, it is a conjugate base of HPO4 2 minus. So that will be for 1 mark. And then question 6 is having a total of 11 marks. That can happen there too.
I don't see any hands in the THEKISO, and I also do not see anything on the chat. I don't know if colleagues are okay, or we have something from Fezile Dabi, Circuit 5.
That I'm happy again.
Yes, Menier.
Yeah, I just want to ask for 6.4. I know the question says write down the conjugate acid-base pair, but that old method, you remember, where kids shall have written the entire equation and indicate with some arrows pairing the conjugate acid-base pairs. Is it fine if we continue with the 2 marks, although they have indicated not written down?
That the THEKISO, what do you think?
I would give, if they are maybe underneath saying this is an acid and a conjugate base, then at least let them label them, not only link them. Because I don't know if they link them what it means.
Yeah, they should link them. I agree with you. They should at least say this pair or pair 1. I remember we used to have pair 1, pair 2, but with an arrow linking them. Yeah. No, we can give that yeah. But there should be a link, with like that is saying.
Yeah, with the description in that I propose, unless if maybe you think for pairing only. But I would say the description is important.
Well,
Because
what do you mean description in here?
Akire, for example, let's start with reaction 1. Akire, the H3PO4 will be acid. Maybe if they write A, and then for water they write B, and on the left for H2PO4, maybe they write C, B, something like that.
Okay. Well, what if a learner has an arrow that is moving from one substance to the other substance, linking them, and then they write a pair?
Yeah,
Yeah, it's fine.
Yeah, I think that we can give. Yeah. Okay. Thank you. Second 5. Are we clear? Are we okay?
Yeah, as long as something is written.
Yeah.
Yeah. Okay. No, thanks in that.
Sharp, Mine. Thank you. I don't see any other hand or comment in the chat. I believe colleagues are okay. Maybe Minir, we can then move on to the last question.
Okay, Minir, question number 7. Question 7 says, during an investigation of the relationship between pressure and volume of a given mass of gas, a group of learners set up the following apparatus. And the apparatus is given there, labeled as well. The learners uses the pump to change the pressure on the gas. 7.1. Which gas law is the learners investigating? Or which gas, yeah. Which gas law is the learner? That's what's supposed to be written. Which gas law is the learners investigating for 1 mark? And then they needed to write Boyle's law. Boyle's law for 1 mark. And then 7.2, for this investigation, write down the dependent variable at 7.2.1. Then the dependent variable will be the volume of the gas. And then 7.22, it says write down the controlled variable. Please, on the memo there, it just needs to, we will fix that numbering. It's 7.22, not 7.21 again. So the 7.22, the controlled variables or variable is the temperature. They can choose the temperature. The learners can also choose the mass of the gas. And then also, Ntate Happy, I'd like to believe we can accept the number of moles of a gas or the amount of the gas. You can guide me there. You can guide for 7.2.2. So temperature, the mass of the number of moles of the gas, the amount of the gas. I believe those as well can be accepted in that Happy. 7.3. The initial volume of all enclosed air is 250 centimeter cubed, and the pressure is 90 kilopascals. 7.31, calculate the volume of the gas in decimeter cubed if the pressure is increased to 140. Then learners can choose this option of P1 V1 is equals to P2 V2, and they will get 1 mark. And then substituting on the left, the initial values given as 90 multiplied by 0.25, you get a mark, is equals to 140 multiplied by V2. Then we get the third mark for substituting on the right-hand side. And then their answer coming out as 0.16 dm cubed, then it will get them the 4th mark. And then here, Tate Happy, I don't know about the significance of maybe not converting earlier. So where you find maybe a learner writes 90 multiplied by 250 then equals to 140. V2, they get their centimeter cubed as probably, I think it will be 160, and then later divide it by 1,000 to get it to the dm cubed. So I believe if that is the case, we can afford them 3 marks if they are not getting the answer in dm cubed. That's what I think, but you will guide that Mohapi and colleagues. Then we move to 7.32. 7.32, it says, use symbols to write down the conclusion for the learner's investigation. And the symbols that we are having there are pressure is inversely proportional to 1 over V. Pressure is inversely proportional to 1 over V for 2 marks. And then 6.33, it says if the volume of the enclosed gas is doubled, how will the pressure of the gas change? You write either doubled, halved, or 0. So if we are doubling the volume, then 6.3.3 on the MEMO, the pressure will be halved for 1 month. 7.4, which is the last sub-question, it says, state the conditions under which a real gas approaches the ideal gas behavior. And then the ideal gas will approach, the real will approach the ideal if there is low pressure for 1 mark and the temperature is high as the second mark. And then the total of question 7 is 12 marks. And the grand total for the question paper is 100 marks. Dr. Mohapi, over to you.
Thank you very much, Ntate THEKISO, for leading us in this MEMO discussion. You have done a wonderful job, Minia. Thank you very much. Before we close it, colleagues, is there anything that colleagues would like to ask? I received a message from Ntate Taitsang. Can you please say something on the message that you sent me here? As Ntate Taitsang is gathering the weights, can we allow Mr. Motsamai?
Good morning once more, Minia. Can we please go back to question 3? Okay, Minia, thank you. If you look at question 3.1, the first question was asking if CaC2 is the limiting or excess agent. And the correct answer there is excess. And then when you move to question 3.2.2, and please bear with me, I understand the physics is wrong, but I was looking for the explanation in terms of the marking criteria there. If the child in 3.1 said CaC2 is the reactant that is limiting, one that was supposed to be in excess, if they chose it to be the limiting one, and they used that information that they gave in question 3.1 to answer question 3.2.2, what do we do in terms of that? How would one mark that question?
Okay, Mr. Motsamai, this is similar to that other question that we answered. I think it was question 5 or something. But now let's then answer how we can afford them the marks. The first formula, the formula of n is equal to m over m has been awarded 1 mark. So we can give them that mark. And then because here specifically, I believe they will still be using 64. So Remember, the 0.125 will be something else that they may be having. So the 0.125 coupled with 64 can still get them 1 mark. And then if they are choosing 8, okay, 8 will be what they have calculated. It must be paired with what was left as 0.7. I believe they will still get that third mark and they will fulfill the answer. So they will get 3 out of 6, I believe. Colleagues, that I'm happy, kindly guide any further. I think they will just get 3 marks for n is equals to m over m using
I want to write it down, so can you just slow it down a little bit? 1 mark for?
They will get that 1 mark for calculating the mass of CaC2, that formula 1. And then also the substitution there, because it will be needing that 64. There's nothing else. It will be needing that 64, multiplying it with something else that is they have calculated there. I believe they should get that second mark, and also taking that calculated value, adding it to 0.7, and then we end there. 3 out of 6. That's what I would guide, unless if there is another feeling. But I'm happy.
No, I agree with you, Miniri. You have explained it very well. Thank you very much. Any other question, colleagues? We have something from Moloi SH Tukwan.
All right, thank you, Ntate. I'm not sure if we have already addressed this. When we go back, and apologies for taking you back to question 4, 4.1, the answer is exothermic. Now, suppose that the learner, I'm looking at the script here. Now, this learner said 4.1, the answer is endothermic. Then going to 4.3, this learner has drawn a graph for endothermic. So is this learner going to get 0?
All right.
Because 4.1, the learner said the reaction is endothermic. Therefore, 4.3, this learner has drawn a graph for endothermic reaction. Is this learner going to get 0 out of 5?
Okay.
Okay. No, thank you. That take this over to you.
Okay. All right. Thank you. If we look at the marking criteria, the Moloi, the learners will still get 1 mark for reactants and products.
Okay.
They will still be indicated. And then their EA forward will be large. And then they won't get that mark. It will be larger than the one for the reverse. So they won't get the second mark. The activated complex, they can still get that mark. The delta H, they can still get that mark. So 3 out of 5, they should get.
Okay, no, it's clear. Thank you, Dr.
I don't know the data keys, but I think they can also get for activation energy.
Okay.
Because again, we want them to indicate the energy from the reactants to the activated complex.
Okay, so meaning even if it's large, you can give
even if it is large, as long as it moves from the reactants to the activated complex, I think they can get is fine. So the learner will just forfeit for the shape.
Okay, so it's going to be 4 out of 5.
Yes, but the learner, remember what THEKISO said in earlier. The learner needs to indicate and draw those lines, those arrows from reactants to activated complex. Okay.
Yes.
Okay.
Yes. They can't just write EA there and then leave it like that. They need to indicate with the arrow that it moves from here to here.
Yes. Okay.
Yes. Yeah.
Okay. Thank you.
Thank you.
Are there any other hands that I'm happy?
I don't see any other thing. Yeah, no, he will come back, I know. No, that will be it. Colleagues, thank you very much for joining this memo discussion once more. Tate THEKISO, thank you, Tate, for leading us in this discussion. Colleagues, please remember to fill in the attendance register. We have an online attendance register that we must fill now, colleagues. Let us fill it now while the meeting is still on. And then if you are in your clusters, remember to complete all the necessary documents. And please, colleagues, after the memo discussion, after you have filled everything, scan those documents and send them to your respective subject advisors, colleagues. Please let us do that. And with those words, I think this is where we'll end with our discussion. Thank you very much. And I don't know if there is anything that needs to be said. In that number, is there anything that we need to say, or we can close the meeting in here?
Thank you very much, Ndate Mapi, and thanks to the colleagues for attending. Thank you very much, Ndate Tunzi, for the dedication and discussing this memo discussion for us. Colleagues, just a reminder that Mapi has said it, we need the registers, colleagues, for the purpose of ensuring that we do report all the positive activities that we are doing for both our learners and the teachers. So colleagues, with that being said, thank you very much, and I believe we'll see you tomorrow again for grade 10 memo discussion. And with that being said, that I'm happy, I believe we can close this session, sir. Thank you very much.
Thank you. Before we close, Moloi, is that an old hand? Yeah.
Oh, yes, yes, that is an old hand.
Yeah, I know it's a legacy hand. No, thank you very much. Colleagues, the meeting